Boom! Yes, folks, Hume again. So welcome to another series of videos in our continuing series where we go through the CSEC mathematics syllabus. This video will be the first in a short series of videos where we're talking about matrices. Alright, matrices is one of the topics that a lot of people start to stumble over where the CSEC math syllabus is concerned. Matrices is also one of the fundamental topics for further work, whether you're talking about pure maths in Form 6, whether you're talking about mathematics courses at UE or UTT or any of the other tertiary institutions locally, regionally, and internationally. Yeah? So in this video, we're going to deal with some of the basics of matrices, just the basic fundamentals, what it is, what are the things that constitute a matrix, and then of course we'll go further into it as we go along. So what is a matrix? A matrix is simply a rectangular array of numbers. Alright, so for example, you might have an array of numbers that looks like this. You might have 2, 3, minus 1, 4. That is a matrix. Alright, you might have 1, 4, 0. That too is a matrix. You might have minus 11, 6, 42. That too is a matrix. Yeah? So usually the convention when we do the matrices in maths is to put brackets around the matrix. Sometimes you'll see the brackets looking like this. Sometimes you'll see the brackets looking like that. That is a minor detail, not important. The most important thing is that the matrix, the numbers themselves are encapsulated in proper brackets. Alright? So I will use curved brackets just for the sake of, that's just my personal preference right here. Alright? So you have that and you have that. Alright? This 42 is a whole number here. Right. So you have 3 examples of a matrix. But watch it. This is also a matrix. Believe it or not. We'll come back to this just now. The convention for these types of matrix is to use the square brackets. We're coming back to that just now. How about, let us say, minus 32, 84. That's a matrix too. Yeah? Etc., etc., etc. So there is any combination of rows and columns, know the vocabulary, rows and columns, that would constitute a matrix. What are the rows and what are the columns? So in this matrix, this here would be row 1, this would be row 2, this here would be row 3. Alright? In this matrix, you only have one row. In this matrix, you have row 1. In this matrix, you have row 2 as well. In this matrix, you have row 1 here and row 2 over there. And what about the columns? What are the columns? Well, in this matrix, we have column 1. In this matrix, we have column 2. In this matrix, you have one and only column. In this matrix, you have column 1, column 2, and column 3. In this matrix, you have one and only column. So anytime you see a matrix, you could get a very quick reading of how many rows and how many columns the matrix has, and that will give what we refer to as the order of the matrix, the rank of the matrix, the, what's the next word I'm looking for? The order, the rank, hold on, I forgot the word here. The dimension. The order, the rank, and the dimension. Alright? Any one of those words could be used to describe the matrix. So for example, in this case here, we have 1, 2, 3 rows and we have 1 column. So this is a 3 by 1 matrix. This matrix here, let me just bracket it off here. This matrix here is 1, 2, 2 rows, 1, 2, 2 columns. So this is a 2 by 2 matrix. This guy here is 1 row and 3 columns. So 1, 2, 3. This is a 1 by 3 matrix. This guy over here, 1 row, 1 column. Sorry, 1 row, 2 row, 1 column. So this is a 2 by 1. 2 rows by 1 column. coming back to that fella just now, right? He need a little special attention. So you notice in each of the examples that I just used here, I would have mentioned the number of rows first. And that is deliberate because that is how we define the rank, the order, the dimension of a matrix. Rows by columns. It is always rows by columns. So in the same way that when you're doing coordinate geometry, you always have the x coordinate first followed by the y coordinate. Whenever you're describing a matrix in terms of the rank, in terms of the order, in terms of the dimension, the sequence is always row by column. That is a standard convention that we adopt when we're talking about matrices. All right? So the convention is always rows, number of rows multiplied by number of columns. All right? Rows by columns. End of discussion. Now, of course, you have this matrix. I didn't put a number there. What madness is this? All right, let me put -1. All right? Yeah. So you would notice in this matrix, you have 2 rows and 2 columns. This is what we refer to as a square matrix. Remember, we define a matrix as a rectangular array of numbers. Of course, the square being a special type of rectangle where the number of sides are equal. That would be taken from your work on question 3, areas, volumes, shapes, etc., etc. Same thing with matrices. All right? So most times the number of rows will not be equal to the number of columns. Whenever the number of rows is equal to the number of columns, that is what we refer to as a square matrix. And the square matrix, just like the square in your regular geometry, the square matrix has a whole set of special properties. There is a whole separate subset of arithmetic where the square matrix is concerned. The determinant and the inverse and the adjunct and the matrix of cofactors, etc., etc. We will deal with some of those a little later on right here on this website. And of course, if you go further on, you'll deal with 2 by 2 matrices. So for the purposes of CSEC, they're not going further than 2 by 2 where the square matrix is concerned. All right, for the purposes of pure maths in Form 6, the CAPE, you will be dealing with 3 by 3 matrices. And usually, even up to university level, in terms of manual calculations, they wouldn't take you past 3 by 3. The idea is, once you understand the concepts up to 2 by 2, up to 3 by 3, then when it is you have to use the calculator to calculate, to do calculations involving a 4 by 4, or a 5 by 5, or a 6 by 6, or 18 by 18 matrix, then, even though at that point the calculation will be automated using a computer, you understand the concept. So you know what a determinant is, even if you don't have to manually calculate the determinant of a 25 by 25 matrix. That might take you about 3 months, right? If you plan to sleep somewhere in them 3 months, right? And that's the basic idea. So the whole point of doing these things, you know, a lot of people, we have this idea that because we live in a computer age where we have access to Google, where we have access to online calculators, where we have access to machines that could do the calculations, there is no need to go through the manual exertion of learning these things. That couldn't be further from the truth. You need to understand what the concepts are. You need to understand the processes involved in calculation so that you wouldn't be using the calculator just and don't have a clue what's going on. It is always better to have a clue of what you're doing, and that's a general principle in life, right? But that's a whole different conversation. Now, as we're on the topic of square matrices, look at our guy here. All right? Most people don't realize that the regular integers that we are so familiar with, those are also examples of matrices. Of course, in this case, we only have 1 row and 1 column. So an integer is an example of what we can call a 1 by 1 matrix. All right? Of course, we don't usually expend any energy to talk about a matrix being a 1 by 1. A 1 by 1 matrix is just an integer. All right? But that is just knowledge. That is just something for you to be aware of. To understand that a lot of the regular algebra that we are accustomed to, in some senses, can be considered a subset of matrix algebra. So you have matrix algebra, which is a whole potpourri by itself. And then you have the regular polynomial algebra, which is the normal thing that we are accustomed to doing. Solving equations, finding x, quadratics, blah, 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 blah. Remainder theorem and factor theorem. All of that is polynomial algebra. Matrix algebra is a different thing. The polynomial algebra is a subset of matrix algebra. All right? Good. So this is basically what it is when we're talking about matrix. Let me see if there's anything else I have to discuss. Yes, the identity matrix. So I'll clear the board here in a bit. Right? Yes, I do need to have the extra aids on hand just so that I wouldn't forget stuff. So anything else to discuss here? No. All right. So let us talk about the identity matrix. All right? Again, we wouldn't go too much into detail of examples of where we use the identity matrix. That will come a little later in the sessions. So the identity matrix is a square matrix. Whether you're talking 1 by 1, 2 by 2, 3 by 3. So the identity matrix of order 1 will be just a regular number 1, which we will put in square brackets. The identity matrix of order 2, which is a 2 by 2, would be, watch it, 1, 0, 0, 1. That is the identity matrix of order 2. By the same token, your identity matrix of order 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is your identity matrix of order 3. All right? So this would be your 1 by 1 identity matrix. This would be a 2 by 2 identity matrix. And this would be a 3 by 3 identity matrix. The symbol that we use to denote the identity matrix is, take one guess, big letter I. All right? Now, we are familiar with this fellow here in our regular algebra. So we know that when they multiply by 1, the thing that they multiply by 1 doesn't change. 6 by 1 is 6. 25 by 1 is 25. Minus 10 by 1 is minus 10. 100 by 1 is 100. Minus 2,385 by 1 is still 2,385. So we know that the operation of multiplication by the identity, it leaves the quantity that we multiply in the identity by essentially unchanged. That is the whole idea, that is the whole concept of identity. The concept is the same in matrix algebra. Right? So if you take some other 2 by 2 matrix and multiply it by this, the answer you get will be the same 2 by 2 matrix that you started out with. If you take some 3 by 3 matrix and multiply it by this, the answer you get will be the same 3 by 3 matrix that you started out with. And of course, the identity matrix for a 4 by 4 will be just the extension of this, 1, 0, 0, 0, 0, 1, 0, 0, 0, blah, 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 going down the same story. So again, once you establish the pattern, 1 by 1, 2 by 2, 3 by 3, you immediately have a very clear picture in your mind of what the identity matrix of rank 4 or 5 or 6 or any other number that you care to choose would be. All right? Now, the next thing we have to mention here is what we refer to as the, and I'm going to write it here now, the leading diagonal. Right? If you have any doubts about what the leading diagonal is, all you have to do is watch the diagonal with the ones in the identity matrix. That's the leading diagonal. as the leading diagonal. Top left to bottom right, top left to bottom right. Of course, this is just a 1 by 1, so that is what it is. And of course, the leading diagonal has its own special properties again within the branch of arithmetic concerning square matrices. All right, square matrices is a whole separate study by itself, which you will do as you get deeper and deeper into the whole topic of matrices. So that is more or less it where the basics of matrices are concerned. Anything else that I need to mention? No. Right, so we could wind up this video here. All right, we're trying to keep the video short and snappy where possible. There will be the odd occasion where we had to go 30 minutes and 40 minutes and whatever. All right, so we just have to be patient. You just have to be willing to be still. That is something that I keep encouraging my students all the time. You have to be still, right? If you have a video and you find it too long, just pause it. Take a 5 minutes, pause. Take a 10 minutes, pause. Whatever your attention span is. Or you could just watch it and pause at a convenient point. So if I'm talking about 3 topics, at the end of the first topic, you could pause, take a little break, and go into the second topic. So in other words, you don't want to use the fact that you're looking for excitement as an excuse not to do your work. All right? As I tell my students all the time, life is not always about excitement. Sometimes life is about production, being productive. Sometimes life is about doing something that may not necessarily be pleasant. Sometimes life is about just grinding your teeth and doing it. And strangely enough, sometimes when you do that, the pleasure starts to come. The pleasure starts to come. The pleasure do always come at the beginning. So as I close this video, I just taking the opportunity to encourage you all again to keep working on this maths, keep working on this particular topic, keep working on whatever else you're doing that is important to you. All right, so in the next video, we will go on to some other topics where matrices are concerned.